Yesterday we looked at trig identities, which are basically proving are true for usually all values of x or a specified value of x, as opposed to trig equations where we're solving to find specific values of x. So something like this, tan theta equals negative 2.3673. There's basically a process you go through. Now, sometimes you don't write all these things down, but the logical way of thinking about it is we need to first of all determine how many solutions they want. And hopefully they'll tell us a range that we're going between. Usually something like between 0 and 360. We then have to work out which quadrants are we in. Well, they've told me tan is negative, so I've got two possibilities. I'm in quadrant 2 or I'm in quadrant 4. Now we're just going to solve it like it's a normal right angle triangle question. So we find the acute angle. We don't worry about the negative sign. Notice I changed the pronumeral because it's not actually theta that I'm finding at the moment. I'm just finding the acute angle. And that would be 67 degrees 6. So that would be the answer if we were in the first quadrant. But we're not. We're in the second and the fourth quadrant. So now we go and solve the actual problem. I've got all the information I need. I know the acute angle. I know which quadrants we're in, so I can put it all together. There's a quick little diagram there. If I'm in the second quadrant and the fourth quadrant, then I want 180 minus the acute angle, and I want 360 minus the acute angle. So subtract 67.6, and I get my two answers. 112.54, 292.54. So basically that's the process we go through when we're solving a trig equation. Work out which quadrants we're in, find how big the acute angle would be, and then tie the information together to come up with our solution. Right, cos theta is a half. Well, it's one of our exact values, of course, but we are going between 0 and 360. So again, we've got two possibilities for this one. I could be in the first quadrant or the fourth quadrant. Well, first quadrant is just going to be my normal answer. Fourth quadrant will be 360 minus that. So let's find that acute angle. 60 degrees, of course, cos 60 is a half. So I'm either going to have that acute angle or 360 minus it. There's my two answers, 60 or 300. Cosec. Well, we don't have a cosec button on the calculator. So first thing I'm going to do here is turn both sides of the equation upside down, turn it into something we can handle with the calculator. So sine theta is a quarter. Sine is positive in the first and the second quadrant. Let's go and find the acute angle, 14 degrees 29. So put those pieces of information together. I'm either going to have the acute angle or 180 minus the acute angle. And there's my two answers, 14.29, 165.31. So same pattern each time. Oh, we've got to play around with this one. 2 sine x plus 1. Remember, the trig is the pronumeral, if you like. So we don't make x the subject. I want to make sine x the subject. So sine x will be negative a half this time. All right, third and the fourth quadrant. The acute angle, 30 degrees. So I'm either going to have 180 plus the acute angle or 360 minus the acute angle. 210, 330. What do I make the subject? Sine theta or cos theta? I've got two different trig ratios, but I can play around with this and turn it into one trig ratio. Because if I divide both sides by cos theta, and also divide both sides by 5, sine on cos is that special relationship, which is tan. And so now I've got something I can handle. Tan theta, negative 2/5. Tan's negative, so I'm in the second or the fourth quadrant. Find the acute angle, put all the information together. So I'm either going to have 180 minus the acute or 360 minus the acute. 158.12, 338.12. Cos 2 theta. You can't factorise the 2 outside of the trig. I mean, it's stuck with the theta. I'm looking for solutions for theta between 0 and 360. Before I can find theta, I have to find 2 theta. So therefore, solutions for 2 theta will go between 0 and 720. I'm going to go around the circle twice looking for answers here. First quadrant and fourth quadrant, still do the same ideas. Find the acute angle, 4125. First quadrant is the acute angle. Second quadrant is 360 minus. So I've got 4125 or 360 minus that, but hang on a sec, I'm going around twice. So I've also got 360 plus that as well. So all I do is add 360. So I got 4125, add 360, I get 40125. 318.35, add 360, I get 678.35. But that's 2 theta. So the final step for this question, divide by 2, and all of those 4 angles now come between 0 and 360. So 4 solutions for that particular problem. Sec squared, tan theta, and they equal 3. This is where we make use of our trig identities. I can change that sec squared to be 1 plus tan squared. And I've got a quadratic equation. The pronumeral is tan theta, if you like. So what multiplies together to give negative 2, adds together to give positive 1, still all the same ideas that we saw in algebra. So I'm going to end up with tan theta plus 2, tan theta minus 1. I now have 2 possibilities. Either tan theta is negative 2 or tan theta is equal to 1. Let's solve. Well, first of all, negative 2. Second quadrant or the fourth quadrant. Find the acute angle, 63.26. Tie it all together. So we're 180 minus the acute, or 360 minus the acute. 116.34, 296.34. That's only half of this problem though. Tan theta equals 1. We're in the first or the third quadrant for that one. Acute angle is 45. Piece it all together. So I've got the acute angle, or 180 plus the acute angle. 45, 225. Now, it's not for whoever's looking at your solution to work it out and go, oh, you got 2 answers over here and 2 answers over there. We write one final one which ties the whole solution together. 4G.